Okay, today on the rate of reaction, I'll be going through drawing different graphs with respect to initial experiment. So let's consider this reaction where you are involving excess 1 mole per dmq of hydrochloric acid and limited calcium carbonate. So the equation is as shown over here. So this experiment over here, where the graphs have been plotted, is where I'm changing my concentration of my hydrochloric acid. So my main focus is 1 mole per dmq of hydrochloric acid, which is the orange graph. What happens when I decrease the concentration? As the concentration of the acid is decreased, the rate of reaction is slower. As such, a graph with a gentler gradient is drawn, as shown in the blue graph with 0.5 mole per dmq of hydrochloric acid. What happens when I increase the concentration of acid to 2.0 mole per dmq? As the concentration of the acid increases, the rate of reaction is faster. Therefore, a graph with a steeper gradient is drawn, as shown in the gray graph. If you look across all three experiments, the volume of carbon dioxide produced is the same at 30 cm3. Now let's consider another case scenario where I have swapped my limiting reagent and what is in excess. In the case of limited hydrochloric acid and excess calcium carbonate, you can see that my input or the output of the volume of carbon dioxide produced for the two experiments are different. Why? Because let's compare the concentration first. We are comparing 1 mole per dmq of hydrochloric acid against 2.0 mole per dmq of hydrochloric acid. So let me draw a beaker. This is beaker A, and this contains 1.0 mole per dmq of hydrochloric acid. You have another beaker B, with the same volume, and this contains 2.0 mole per dmq of hydrochloric acid. Because 2.0 mole per dmq is of a higher concentration than 1.0 mole per dmq, there will be more reactant particles in beaker B. So that's why I'm going to draw more reactant particles. But for beaker A, because it has a lower concentration, there will be fewer reactant particles. Because beaker B has more reactant particles present, the volume of carbon dioxide will be greater than that of beaker A. So when the concentration is 2.0 mole per dmq, a graph of steeper gradient is drawn because the rate of reaction is faster. The mole of hydrochloric acid is twice that of the original curve, and therefore the yield of carbon dioxide should be twice the original. What happens when I halve the concentration of hydrochloric acid to 0.5 mole per dmq? What happens to my graph? The concentration of the acid is decreased, therefore the rate of reaction is slower, and a graph with a gentler gradient is drawn. The moles of hydrochloric acid is half that of the original curve, and therefore the yield of CO2 should be half the original. So there are two things which you need to take note in determining the shape of the graph with different conditions. The first is the change in the rate of reaction. Higher rate equals to steeper curve, lower rate equals to gentler curve, and when there's no change in rate, it means the same gradient as the original curve. Then you also need to look out for whether there's any change in the yield of the product. For example, if it's half the original mole of the reactant, then the yield produced will be also half of the original. And that is 2 minutes of chemistry. See you next time.